Hi, and welcome. In this video, I will explain the simple physics behind launching a rocket into low Earth orbit. Alright, let's go through this step by step. We have a rocket that's trying to reach low Earth orbit. Its initial mass is 500,000 kilograms, and after it burns fuel, its final mass is 100,000 kilograms. The exhaust velocity is 3,000 meters per second. Its thrust is 7,500,000 newtons and air resistance, or force of drag, is 200,000 newtons. First, we want to figure out how much total velocity this rocket can gain. That's what delta V represents. Using the rocket equation, we take the ratio of the initial mass to the final mass. In this case, 500,000 divided by 100,000 gives us 5. Then we take the natural logarithm of that ratio, which is about 1.61, and multiply it by the exhaust velocity. That gives us a total delta V of about 4.8 kilometers per second. Now, let's interpret that result. To stay in low Earth orbit, an object needs a horizontal velocity of about 7.8 kilometers per second. So right away, we can see this rocket does not have enough total velocity to reach orbit. But that's only part of the story. Now, let's look at the forces acting on the rocket during flight. The rocket has thrust pushing it upward. At the same time, gravity is pulling it downward with a force equal to its mass times g, and air resistance is also acting downward, opposing the motion. So the net force on the rocket is the thrust minus gravity and minus drag. According to Newton's second law, that net force determines the rocket's acceleration. And this is really important, because it means not all of the rocket's thrust is actually increasing its speed. A large portion of it is constantly being used just to fight gravity and air resistance. So even though we calculated a delta V of 4.8 kilometers per second, the rocket doesn't get to use all of that purely to speed up. Some of it is effectively lost overcoming those forces. Now think about what happens if the rocket just goes straight up the entire time. In that case, it would spend most of its energy fighting gravity, which is extremely inefficient. But orbit isn't about going straight up. It's about moving sideways fast enough to stay around the Earth. So instead, rockets tilt during flight. As they tilt, some of the thrust is redirected horizontally, allowing the rocket to build sideways velocity. This creates a curved path, where the rocket is moving forward while gravity continuously pulls it downward. If the horizontal speed is high enough, the Earth curves away beneath the rocket at the same rate it falls. That's what an orbit actually is. Continuous freefall with enough sideways velocity to never hit the ground. So, to answer the original question, no, this rocket cannot reach low Earth orbit. It doesn't have enough total delta V, and it also loses additional energy to gravity and air resistance. And more importantly, this is why rockets don't just go straight up. They have to turn and build horizontal velocity to reach orbit. If you reach the end of this video, make sure to like, subscribe, and comment down below what I should do next. Thank you for watching.